Let's take a look at our last type of equation for lesson 4.4. Now we're going to look at equations that have different trig functions and different arguments inside of them. So let's start with this. Let's start with, we know that this is sine of 2x, which means I can use a trig identity on that. I know sine of 2x is 2 sine of x cosine of x. Now, just like we've done before, let's try to bring everything to one side and see if we can factor this into something that looks a little bit nicer. So I have 2 sine of x cosine of x minus root 3 cosine of x equals 0. And I notice right away they both have a cosine in common. So let's take a cosine of x out. And now that I've taken that out, I can set each factor individually equal to 0. And you know what to do from here. So at this point, I want you to pause the video, solve each of these individually. They are both unit circle problems. And then find all your answers that are on your unit circle from these two equations. Pause the video and try that out now. Let's check your work. So I solved the first one to get x equals arc cosine of 0. So where on the unit circle is the cosine value or the x value 0? That happens at pi halves and 3 pi halves. So there's my answers. And I solved the other one and I got x equals arc sine of root 3 over 2. So where on the unit circle is the y value or the sine value root 3 over 2? Well, that's these two triangles right here. They both have a y value or a sine value of root 3 over 2. So that would be at pi thirds and 2 pi thirds. One more problem and then we're done with this lesson. So let's look at example 6. We have sine of x cosine of x over 2 plus cosine of x sine of x over 2 equals 1. So we have multiple trig functions, sine and cosine, and multiple arguments, x and x over 2. This might trick you up a little bit at the start, but if you notice one thing, you'll notice very quickly this isn't as hard of a problem as you think. And that one thing is sine can't change signs. This is a trig identity. In fact, it's the sum and difference identity for sine. Sine can't change signs. So if we change this to the sine sum or difference identity, it would become this. We know it's plus because sine can't change signs. And then we add the arguments in. Now I can simplify this. 1x plus half an x is 3 halves of an x. And I can work on solving this now. Arc sine of both sides. So I got 3x over 2 equals arc sine of 1. So I need to find where on my unit circle is the sine value 1 or the y value 1. That only happens up here at pi halves. Now, one thing I want you to recognize, realize the x is not alone. That means I need to start by listing my all and then narrow it down. So I have 3x over 2 equals the only point where arc sine of 1 is, or where the sine or y value is 1, is pi halves. So I can do pi halves plus 2 pi k. That gets me my all. So I start right here at this one, and I go around 2 pi to get it again, around 2 pi to get it again, and so on and so forth. Now I need to solve for x, so I'm going to times everything by 2/3. And I just realized I wrote 2/4 up there instead of 2/3. So let me try that again. So when I multiply everything by 2/3, those cancel and I just get x. Those cancel, I get pi thirds, and I get 2 times 2 over 3, which is 4 pi thirds. Okay. So if it wanted me to list all my answers, that's what I would do. If it wanted me to list all my answers from 0 to 2 pi, I would start with pi thirds and list them until I get bigger than 2 pi. So pi thirds, and I'm going to add 4 pi thirds to that. That gives me 5 pi thirds. I'm going to add, that is still less than 2 pi, so let's add 4 pi thirds again. That is 9 pi thirds, which is bigger than 2 pi, which means those two are my answers. So that is solving some more complicated trig equations. Hopefully you can start your homework now. The equations do get more complicated, but don't forget our tips and tricks from the beginning, using your identities and using factoring, and that should get you through it.